Okay. It's really nice to be here in Nairobi and some familiar faces that I'm seeing today and a lot of new faces who I hope, I would become friends with. So my talk today is actually about monitoring and observability. And we're going to get down into all of that. So my name is Anthony Alaribe. I'm the founder of a company called API Toolkit, which is it's a monitoring and observability company. But that's not what today is about, even if there would be some of that, during this workshop. So by the time we leave here, at the end of this talk, I hope that everyone here would know how to, make the systems that we build an open book. In other words, when you build your next Facebook, your next OpenAI ChatGPT, you would have all the tools you need to make it observable, to make it easy to understand what's going on in there. So now let's start the questions. What is observability? It's about seeing what's going on. So it's about having those eyes into a system, right? It's the process of having those eyes into a system. So let's try another question. So what is OpenTelemetry? Has anyone heard of that term, OpenTelemetry?
Okay, my name is Fatuma Abdullahi. OpenTelemetry is like a set of open tools that try to standardize, I think, the process of injecting or having observability. It covers metrics, logs, and a third thing that I have forgotten.
Everyone has said is that it's a bunch of tools, right? So we discussed observability being the process of having eyes into your system to know what's going on. Now, OpenTelemetry is a standard. So before OpenTelemetry came around, every observability vendor had to create an SDK, create a bunch of tools which you would use in instrumenting your system in making your system observable. So Datadog would have theirs, Honeycomb had theirs, etc. Now, the disadvantage of everyone having their own set of tools is that, let's say you work in a company with 20 microservices or 100 microservices, and you're using Datadog, and Datadog got very expensive. What do you do? Because when you start to think about how much effort, if I want to switch from Datadog to the next provider who might be cheaper for my use case or even maybe better for my use case, I have to update all of these 20 services, go into their code, change this, change that, and maybe it's many person weeks. And then you just end up sticking to Datadog because you kind of get locked into the ecosystem. But OpenTelemetry is a bunch of these vendors. Honestly, it was a bunch of the smaller vendors coming together and saying, okay, how about we agree on a standard? How about we agree on a set of languages that we can communicate with? Can we say, okay, if there is a method should be http.method. If there is a URL should be http.url path. Something like that. So they agree on this language, agree on the transport, the protocol of sending these messages from your service to the vendor, so that if you want to switch vendors, you don't even have to touch your code at all. You probably just need to update a bunch of environment variables, change the destination URL of where you're sending those logs, metrics, traces to, and it's going to be there. So let's move on a bit. So we've learned that observability is making your system like an open book. You can see what's going on. So what then is monitoring? And what's the difference between both of them? Monitoring is an active process. Observability is passive. So what does it even mean when we say something is passive and the other one is active? So I'm going to give a small example. So let's say you have a backend, you're building a fintech service, and you decided to log every single thing that happens. When a request comes into the handler that handles the request, you log request came in. When you read to the database, you say read from the database. When the user did a transaction to send money, you say user sent money. So now you've logged every single thing that's going on. This is good, right? No, it's not very good. But in any case, you've sort of made that system observable because the system is spitting out a lot of information, which can be very valuable if, for example, something goes wrong and you want to investigate what went wrong. But the problem is that these logs are a lot. But you have that information because you're emitting those logs. Now, what happens if you go into some tool, whatever tool that handles your logs, and then you say, if any log that contains this error message, user not found, happens, send me an email. Now you've set up monitoring for those logs. Does that make sense? So observability is about just emitting those information. Now monitoring is actively checking if either the information is correct or some invariance that you're checking for is true. So if you say, okay, there must always be a user in my database, then you can set up a monitoring to check, maybe check every minute. If there is no user in the database, then someone gets notified. But that's log monitoring. So there's log monitoring. There's also other kind of monitors. For example, let's say you have the same fintech app, and the most important action in your fintech is to send money. So you want to make sure your platform can always send money no matter what. So you go into API Toolkit or any tool, Postman, and then you say, okay, this is the request for sending money. I have to hit /transfer, and I have to give this account number and these other details. And the response should always be transaction successful. So you test it in Postman, transaction was sent. This is not monitoring yet. Now, monitoring now happens when you make it happen on a schedule, or you make it happen consistently. And then you say, okay, every 1 minute, hit this endpoint, try to send this money somewhere. Now you have a monitor. You're monitoring that transaction's endpoint. If the transaction endpoint is not working, something is you're gonna get notified, something is gonna happen. So now is it clear the difference between observability and monitoring? So with observability, you can spit out all the information you need. With monitoring, you can check that information or even check the system itself to make sure that things are the way you want it to be. And if something is not okay, maybe you can get notified or something like that. Okay. So I think I mentioned why you don't want to log every single thing, because the information will just be so much. Who here actually looks at their logs? Who here actually manages an app in production? So only one person has an app in production? 2 people? What are you guys doing at this conference? Are you at the right place? So what do you guys manage? Apps in staging? So, and I don't know who's managing apps in production now. Okay, let's put it like this. Who here looks at their logs every day? Okay, 2 people? Thanks. How about every week? Okay, more people? 5. How about every month? So you only go to the logs when something goes wrong, yeah? To be honest, 90% of companies do exactly what you described. So you put an app in production and then you wait for your customer to tell you that something is broken. Then you go look at the logs. What broke? But the truth is, logs are continuous. So you have all this information just coming in constantly. I don't want to spend all my day looking at logs. Also, it's not even practical. I'm just going to be looking at the logs constantly. So how then are we supposed to, we already spoke about monitoring, so I guess you kind of know how you're supposed to catch when something goes wrong. But even without monitoring, we're focusing on observability for this talk. There are these 3 pillars of observability. There's logs, there's traces, there's metrics. So let's rush through some of these. And then what about, okay, we've already learned that traces are like, I think I was describing that traces are like logs. The main difference is that they have the timestamp. The first request that comes in has an ID. So usually called the trace ID or the first span ID. And then every action that happens, say you have to go to Redis, you hit Redis, you create a log for that Redis call, and then you give it an ID again. So that span, that operation, you give it a span ID. But then you also give it a parent ID, which is the initial request that triggered the Redis call. So what happens is that traces become this tree of, okay, this happened, then we had, while handling this guy, we had to do this other thing, and then we had to do this other thing, right? And yes, it's a log, but because of this tree structure, it becomes possible to visualize it in many different ways. I'll show you an example. Do I have a screenshot somewhere? So this is an example of a flame graph. This is how we visualize traces on API Toolkit. So this is an example where a request came into the server, so it was a GET request, and we know that this request took 4 milliseconds. Very fast server. That's what I always write, eh? So we know that when this came, in this server, it took 4 milliseconds, but this server needed to do a bunch of other things to satisfy the request. For example, it had to, so this is like I don't know. But anyway, this service had to make a call to some other service. That's this one. And to get here, it had to pass through an ingress, and it had to pass through a router front end, and then it now got to this service. And then this service had to make another GET request for this. And then this guy had to make a gRPC call for some data. And then during this gRPC request, it had to do something else, like a database call. But it's just imagine a microservice architecture that has like 3 different services, or 3, this is a database, right? So you can see the full breakdown. You can see that, okay, we had to hit this service, we had to do gRPC here. So why is this useful? I love to blame. I'm like you. So when you work in a company that has so many microservices, it's very sweet to blame. You're like, why is this request so slow? It's not my fault, it's this guy. Why are you returning your request in, these are good timelines, but why are you returning the response in 2 milliseconds? So you can kind of visualize exactly what is going on, what are the different components, how long are they taking, and this flame graph is mostly showing time, duration. But within one service, you can also visualize other things like CPU time. So if you have one service and maybe you had a request that is super slow, you can see the breakdown and say, okay, these are different function calls. It's not just service. Sometimes you can do, or not sometimes, you can decide to trace function calls. Let's say you do some calculation that is very slow, very expensive, and then you see that function call, and instead of time, you can say, okay, how much CPU, I guess CPU clock speed, CPU time is still time anyway, but how much time is each of these function calls spending on the CPU? Does that make sense? So that's traces. So there's one last thing, which is metrics. One of the points of metrics is that when you put a number to it, it becomes possible to analyze it with statistical methods. So with logs, you have all of these log lines. We just discussed how it's usually too much information that no one even bothers looking at the logs except something goes wrong. Usually when their customer tells them that it's not working. But we've all agreed on that. But if you put a number to some of these things, for example, let's say you had something, you were tracking errors, and one of these graphs was errors, and you see that error went, maybe this is not really error, but let's say error went high. It's easier to look at a graph like this than to look at 1 million logs to catch where something went wrong. True or false? So the whole point of metrics is that you can statistically analyze them, right? So this starts some example. This is like a latency how fast, how slow some service is. So you see like P50, P75. Percentiles basically means, so let's say this graph, I think this, okay, P75. So this is P75. So the P75 mark says 15 milliseconds. So that means that 75% of the requests on this server are handled in 15 milliseconds or less. So it's always or less, everything below. So some might be 0 milliseconds, some might be 10 milliseconds, but 15 or less. And that covers 75% of the people. So that's just basically what percentile means. So P90 means 90% of the requests are handled within 25 milliseconds, based on this graph. But in any case, by putting those numbers, you can plot all of this, and you can understand. So you can have a server where the P99 is 1 minute. So it's super slow. But then you see that the P99 is 1 minute, but then the P90 is 10 milliseconds. So maybe a handful of people had 1 minute, but it's probably not worth investigating, right? It might be like an exception. So it gives you that understanding, okay, 90% of my people still get this request in very, very fast time, so maybe I don't need to worry about it. But in any case, that's what metrics are about, hard data points. This is the culmination of that whole talk that I was talking. So how would you actually handle your systems? You'll set up a metric for the things that matter. And why is that? If something goes wrong, at a glance, you would usually see it in the metric. So if you look at the graph from before, do you see this spike that went below? So on this moment, most of the requests from this blue endpoint were not being handled, were not coming in. So if I just look at this, I know, okay, fuck, something is going wrong. Maybe I can go into my logs to check. But you don't go into your logs yet. You know that something is wrong. What's the next thing? You want to pinpoint where the issue is coming from. And that's what traces are for. Right? So you see the whole distribution. We do this, we do that, we do that. So in the whole get request has a problem. But where in the get request is that problem coming from? So you can spend your time at that point. So it might be that the issue, when you look at the traces, you might see that the issue is coming from maybe, I don't know, making the Postgres call. Does that make sense? And with metrics, you can easily create monitors. You can create a monitor and say, okay, this metric, my latency is always less than 15 milliseconds. So if it goes above 15 milliseconds, notify me. So you don't even have to go and look at the chart every single day. You can just get notified when that spike happens. And then you can investigate. Not only when your customer calls to complain. All right, I'm done. Did you guys learn anything? Are you sure? Okay. So I'm more or less almost done. And then we can look at some code together, if there's some time, but no pressure. We already know what OpenTelemetry is, so I don't need to go through definitions. But we've already discussed that it's a standard, right? And the whole idea is that you can switch vendors without, you can get all those logs, metrics, traces. So we're going to look at OpenTelemetry, how it's done. It's a very short process, or it can be a short process, depending on your tech stack. I'm looking around because I have some people who are going to hold me on my neck after this if I say the wrong thing. So you can produce all of this stuff with OpenTelemetry, but you have to send it somewhere. So there are many ways of sending this information somewhere. There's something called a collector, which we're going to look at briefly, or maybe not. And then you need something, Fatima, to query and visualize it. So this will collect the information, but you still need to visualize it with something. You can be a rock star and just put it inside Postgres and write the queries yourself, and So this collector is basically, so this information is coming out of your server. You have to send it somewhere. If you're building a system that has 100 services, you're doing many, many million requests per minute, sometimes it's easier to just, instead of all these 100 services sending information to some weird website somewhere, it's sometimes easier to send it to one central service in your cluster, batch them, and then send it to where it needs to be sent. So that's what this collector is for. So for a lot of people, you probably don't need the collector, depending on what you use. For example, we host a collector where you can just send the information there without you managing a collector yourself. And then, yeah, let's proceed. So this is what your system might look like with OpenTelemetry. So you have a bunch of different services which you integrate an SDK in, and then they send information to a collector. This collector might be in your cluster, or you can just send it directly to whichever vendor you're using, since they probably already have a public collector you can use anyway. And then visualize it and query it. All right. All the talk is over. So basically, this is actually React code. I was talking about like how you can instrument a front-end React.js application. But we'll just stick with the Go for now, especially with the timing we have. So I think I have a better example down here. So I'll just copy this code and then I explain what's going on here. So let's do this. I need both hands. Oh, thank you. So main.go. Is this too small? Can you see my screen? Can you see what I'm typing? Can you see this code? Okay. So all of this code came from ChatGPT. Don't judge the code. But let me explain what's going on here. So we have a very simple main function. And we're using Gin here just as a quick example. So there's an endpoint, a get endpoint, /endpoint, right? And in this endpoint, what we're going to do is that we're going to make a call to another service, a Node.js service. So we want to do like distributed tracing. So that is a very simple endpoint. But now we want to instrument it so we can track everything that happens in this system. So this is making the call. So we are going to assume that there is a Node.js service running on port 3000. In the beginning, there will be no service. So let's just run this quickly and then. Okay. So go. Actually, I have to do go mod in it, but let's see. How many people here have written Go before in their life? So let me see, 10% of the crowd. So the other people, you've never written Go, but you're interested in the language. So maybe I can try to explain in a bit more detail then. So I've set up a Go service. It's a very basic Go service. Main function is where is the entry point. Where is it? So this is the entry point. And I'm going to try to run it. Go run main.go. Imported and not used. So let's just go remove that. 16. T. So when ChatGPT gives you code, you have to fix its bugs. So now it's running. So that means that if I do a curl to localhost 8080, we get a response. So this response error occurred is because, sorry. So what we're doing in this code is that when we make a request to this root endpoint, we're going to call a Node.js service. And whatever response we get from the Node.js service, we're going to return it to the caller. But if there was an error, then we're going to return the message error occurred. Does that make sense? I think I could actually just put the response, but it's okay. Blah, blah. Very simple service. So let's instrument this. Let me explain the OpenTelemetry bit. So with OpenTelemetry, you need to specify a bunch of things. You need to specify where the request is going to be sent to. That's what this exporter is. So this exporter that ChatGPT gave us is just going to print out everything that's happening to standard output. But we can decide to send it somewhere else. And we'll do that in a bit. We will decide to send it somewhere else, and then we can give the service a name. So this is what's going to identify where this particular service that is handling the request. So that's the service name, Go service, right? That's basically all you have to do. So this init tracer is going to initialize everything. And then we have the tracer, which we can reuse at different points. So here now, when a request started, we say, okay, this request has started. We've given it a name, handle request. I'm going to show you all of this now. So this is, remember we're logging the traces to standard output. So when a request comes in, we are logging everything. So this is what a span looks like. You can see the handle request span. Let's look at this again. You see that we named, when a request comes in, we started a new context. Everything that happens here will be called handle request. So that's what that handle request is. Sorry, I should have done this differently. So let me just do this differently so it's easier to switch. Okay. Cool. So it's easier to switch now. So we can see these are the traces. So like I said, a trace is basically like a log. And it's just like a huge JSON log. It's the job of the tool, the vendor, to take this information and represent it in a way that, as a mere mortal, I can understand, right? So what would that now look like? Let's go into like API ticket, for example. I think I have that in here. So what that would look like is that we would then see the requests that are coming in, but if I'll go into traces, since traces is what is important to us today. So remember, what is the name of that service that we created? We called it Go service. We called it Go service, right? So in here now, you see that all of these traces are coming from Go service. So we're seeing all the different actions that happened while processing this request. You see that there was a HTTP GET, then there was a GET connection operation happened on the server, then this DNS operation happened, then blah, 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 blah. But let's just expand one of them. So this is not a very exciting request. So you know what? For ease of just showing you around, we'll just look at something a bit more interesting. Explorer. What's going on? So I decided to just go to like a demo project. The internet is a bit slow, and we don't have much time to instrument properly. But what it would look like is that you see the different, this is a demo service, this is not what we just instrumented. So you see like we have different services, and you see the different things that the services are handling. For example, you can see that this is a Redis HGate. So there's a Redis call, this is a post request, this is a gRPC request. So let's just expand one of them and see. So you see like how it is as a breakdown. So we have the post request that comes in, and then all the different things that we had to do along the way, right? And how do we do all of this? It's basically with this code that we just see. You initialize a tracer, and then any bit of code that is interesting for you that you want it to show up on the graph like this, you can create a span, a custom span. So there's something called auto instrumentation, right? Which is where, without having to write all of the spans manually yourself, you can get all this information for free. Now, the support of auto instrumentation in Go is still new, is younger, because Go is a compiled language, so sometimes doing some of these dynamic things are a bit more difficult. But I can show you what it looks like in maybe some other language like Node.js. I imagine there's some Node.js developers here. Gophercon, okay. Okay, we'll just look at the documentation, just so I can rush through this zero code in instrumentation. So in a lot of other languages, and there's a few that support this, like .NET, PHP, Python, Java, JavaScript. In Go, like I said, it's still new. You see the page is kind of empty because the feature exists, you can actually use it, but it's still in like alpha, so you have to do a lot of configuration, and I don't want to bore you guys with that for today. But I imagine in the next month, this would be like, actually ready for prime time. But in other languages, how you instrument is super simple. You can actually instrument a Node.js app without editing the code at all, or even a PHP app or .NET with OpenTelemetry. All you have to do is you have the project, you run this npm install, you set a bunch of environment variables, and that's all, and you run your app like normal. And all that information will just get sent to whatever provider you put in this endpoint here. Here's an example. Any questions so far? Have I successfully confused everybody? That was my stretch goal. Yeah. So this is an example Node.js app that was instrumented with API Toolkit, and you can see that that was instrumented with OpenTelemetry, sorry. And you can see that there's not so much going on other than just logging different things. And this particular service would make a database call to Postgres. I had a lot of fun, and I'm very happy to be here in Nairobi. You guys are amazing engineers. This is a very amazing tech ecosystem. Thanks to Marvin and the crew for making this happen.